Today we are going to start topic functions, that is exercise 1.2. Okay. Functions. So in class 11, what we have learned? Prince, can you share? क्लास 11 में क्या क्या सीखा था?
So about functions and relations in the second chapter.
No, in class 11 में क्या मिला था हमें functions के बारे में? What was the definition of function? Function is a one type of relation, right? Where every element of domain has one and only one image in codout. That type of function is called functions. एक बार फिर से repeat कर रहे हैं. The function is a one type of relation where every element of domain has one and only one image in codomain. That is called function. So here, like relation, we'll get domain, range, and codomain. So domain was what? Collection of first element of ordered pair. That is domain of a function. Suppose a function f, suppose n to n, right? And define as fx equals to 2x plus 3. Okay, so here domain is what? All natural number. Domain of this function will be set of natural number, right? Acha, then codomain, codomain is always second set. So here second set is natural number, so natural number. But what will be the range of these functions? If we put n equals to 1, what will get?
We will get 5.
We'll get 5. If we'll put x equals to 2, then what will get?
7.
7. If 3 if we'll put, then what will get?
9.
4 if we'll get, then what will get?
11.
Like that it will come. That means collection of all images will be the range of that functions, right? So this much we have learned in class 11. Now here we learn types of relation. In class 12 we learn types of functions. Many types of functions we are getting. Out of that, 2-3 type of functions we have to learn. Number one, one functions. Okay, its another name is one function will be injective functions. onto functions. Its other name is surjective function. If a function is one and onto, then that is called bijective functions. Okay, so these type of functions in 1.2 we learn. So to understand this, I'll show one video, just observe it.
In this module, you will learn about different types of functions. Take a look at the diagram. It shows the graphical representation of the function f1 from a to b. On representing the given function in roster form, we obtain a set with 4 ordered pairs. Observe that different elements of set A have correspondence with different elements of set B. That means the images of different elements of set A under F1 are different. We can also say that no 2 ordered pairs have the same second coordinates. Now, take a look at this diagram. In this case also, the images of the distinct elements of set A under F2 are distinct, or no 2 ordered pairs have the same second coordinate. Such types of functions are known as 1-1 functions. Let us define it mathematically now. A function f from a to b is said to be 1-1 if the images of the distinct elements of a under f are distinct. That is, for every x1 and x2 in the domain of f, f of x1 is equal to f of x2 implies that x1 is equal to x2.
Okay, now try to understand this. What is the meaning of it? So if a function, if we'll consider, just I'm explaining this simultaneously, then you can understand. Okay, suppose a function just consider fx equals to two x, only 2x I have taken. Suppose f equals to f such that it is natural number to natural number and define as fx equals to 2x. Then what we'll observe, suppose this is domain and this is codomain. So here domain is natural number and codomain also natural number. So natural number start from 1 and its image will be 2. Now image of 2 will be 4. Image of 3 will be 6. So what like that we'll get, all I am not showing. Now what we are observing, if x1 not equals to x2 implies fx1 also not equals to fx2, right? Okay, Prince.
Yes, sir.
If x1 not equals to x2, that means if distinct element of domain if you take, then its image will be also distinct. Either this you can tell, in other language you can tell, if fx1 equals to fx2, then x1 should be equals to x2. Any one definition we can use. If you'll prove it is 1 1 or not, then we'll use second one. And if you want to check, suppose it is not 1 1 function or injective function, then we'll take example.
First,
Okay, distinct element of domain will consider if we are getting same image, then we can say that it is not a injective function. So here two types of definitions we will use. If we are proving if it is injective, if it is 1 1 function, then we'll use this concept. If fx1 equals to fx2, implies x1 equals to x2. But if you prove, if you know that it is not injective, then we'll take distinct element of domain, and if you get same image for both the elements, then we can say that it is not 1 1. Okay, so two definitions you will remember. Now listen next part.
Or, if f of x1 is not equal to f of x2, then x1 is not equal to x2. A 1-1 function is also known as an injective function, or simply an injection. Further, if a function is not 1-1, then it is known as many 1. For example, function f shown here is not 1-1 as two distinct elements, 3 and 4, of set A have the same image, -3 under f. Hence, function f is many 1. Look at functions f and g. To check the functions for injectivity, we consider any two different values in the domain of function f and check that their corresponding outputs are different. In the first case, different elements have different images. Therefore, the given function is 1, 1. However, in the second case, the image of 9 and 23 is -4. It means that g of 9 and g of 23 is equal to -4. Hence, the function g is not 1, 1. Moving forward, let's now show that the function f from R to R, defined by f of x is equal to 2x, is a 1, 1 function. Let x1 and x2 be any two arbitrary elements from domain R of function f, such that f of x1 is equal to f of x2. Now, f of x is equal to 2x, so f of x1 is equal to f of x2 implies that 2x1 is equal to 2x2. This gives x1 is equal to x2. Hence, for any two arbitrary elements, x1 and x2, in the domain of f, f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, function f from R to R is 1 to 1. This diagram shows the graph of the function f of x is equal to 2x. Given the graph of a function, you can check whether it is 1 to 1 or not with the help of a test known as the horizontal line test. To check the injectivity of the function f of x is equal to 2x, we draw a horizontal line such that it cuts the graph. This line cuts the graph only at one place. Such types of functions are known as 1-1 functions. In this graph also, the horizontal line is intersecting the graph at only one place. Hence, the function is 1, 1. In cases where the line cuts the graph of a function at more than one place, the functions are not 1, 1. This diagram shows the graph of a function that is not 1, 1. Let's now discuss the onto function. Let's begin by considering a function f from a to b, which is shown here. From our previous knowledge, we can find the codomain and domain of the function. The codomain of function f is set B, with the elements 5, 6, and 7, and the range of the function is also the same set. It implies that the range of the function is equal to the codomain of the function. Such functions are known as onto functions. Mathematically,
So now here, have you understood, Prince? What is
Yes, perfect.
what is onto function? In case of onto function, codomain of that function and range of that functions will be equal. That means no element of codomain will be free. That means every element of codomain is image of any one element of domain. So here we can say that range and codomain both will be equal. If range and codomain are equal, then that kind of function is called onto functions. So in case of 1, 1, if every element of domain has, if distinct element, if we get distinct image in codomain, that is 1, 1. And in case of onto, if codomain of functions and range of functions both are equal, that type of function is called onto. So now
function
next.
f from a set A to a set B is said to be onto if and only if for every element y of B there is an element x in A such that f of x is equal to y. This implies for every y in the codomain there exists at least one x in the domain. So we can say that the range of f is equal to the codomain of f. Hence, f is onto if and only if f of A is equal to B. The other name for an onto function is surjective function or simply surjection. The functions in which two elements are mapped to the same element are also onto, provided there exists a pre-image of every element in the codomain of f. For example, function f from A to B is onto. However, g is not an onto function since the element 4 in the codomain of g does not have any pre-image in the domain. In this module, you will learn about bijective functions. You have learned that a function f from A to B is said to be 1, 1 or injective if every element of A is mapped to a unique element of B. That is, no two elements of A are mapped to the same element of B. Here function f satisfies this condition. So we can say that f is 1, 1. You have also learned that a function from A to B is said to be an onto or a surjective function if every element of B has at least one pre-image in A. Here, function f satisfies this condition also, and hence it is an onto function. Thus function f from A to B is both 1, 1 and onto. Such a function is also known as a bijective function or a bijection. Mathematically, a function f from a to b is a bijection if it is both 1, 1 and onto. Consider a finite set X with the elements a, b and c. Let us define a function f from x to x such that it is a 1, 1 mapping. Then every element of domain X has its own unique matching element in codomain X. That is, two elements from the domain of F cannot point to a unique member of codomain X. So the range of function f has three elements, a, b, and c. This shows the range and the codomain of the function f are equal. Recall that if the codomain and the range of a function are equal, then the function is onto. Hence, the 1, 1 mapping, defined from x to x, is also an onto mapping. More generally, for a finite set X, a 1, 1 function f from x to x is necessarily onto. Also, an onto function f from x to x is necessarily 1, 1 for every finite set X. Let's prove it. Consider the same finite set X and let f be an onto mapping from that f is not 1 to 1. That means two elements from the domain of X are mapped to the same element in the codomain of F. Suppose B and C are mapped to A under F. Now, we are left with one more element, A, in the domain of F that can be mapped to any one of the remaining two elements in the codomain of F. Let A be mapped to B. This shows that the range of the function is not equal to the codomain of F. This is a contradiction to the fact that the range and the codomain of
So your
F
screen
are
is not
equal.
shared.
Now can you see?
Yes, sir.
Function defined from a finite set to itself is always 1, 1. In this module, you will learn about
Okay. So here we have understood the meaning of 1, 1 functions, onto functions, okay, or injective and surjective functions. Okay, if a function is injective also and surjective also, that function is called bijective
Bijective.
functions, right? Okay, so
Yes.
a little bit I'm explaining, just try to understand. So what we have learned, number one, 1, 1, 1, 1 function. Okay, that is or injective function. Injective functions. So what type of questions you will get? Number one, suppose it is 1, 1 function. Okay, so how you will write that pattern I am showing you. Here you will use this symbol for all. x1, x2 belongs to domain. Right. After that you will write fx here, fx1 equals to fx2. So function will be defined. So fx1 you can write, fx2 you can write, and if you can prove x1 equals to also x2, And here you are considering for all element of domain. So every distinct element of domain has distinct image in codomain. Therefore, we can say that f is 1111 function. Right. Second type of questions. Suppose it is not 11 function or injective function. So here you will consider any two element you will consider. Let x1, x2 belongs to domain. Okay. Then after that you will find fx1, you will find fx2, and if you will get both are equal, that means here you have taken x1 and x2 distinct element. But if you will get here both are equal, that means if fx1 equals to fx2, then you can say that f is not 11. Okay. So f is not 11 or injective. So these two pattern you will follow. Understood? Because that technique is very important to how you'll write. Sometime now we'll understand, but we don't know how to write the answer. If properly if you'll not write, then you will not get marks properly, right? Okay. Now
Yes, sir.
second type, onto or surjective. Onto or surjective function. So how we will prove this? So here let y be any element of codomain. That means you are considering arbitrary element of codomain. So we know that fx equals to y. So x equals to, you will get in term of y, suppose gy you got function of y in term of, if this belongs to domain, if gy belongs to domain, then we can say that every element of codomain has pre-image in domain. After that you can, that means what? That means range equals to codomain. If every element of codomain has pre-image, it means range and codomain both will be equal. After that you can write f is onto or surjective. This is first type. if it is onto, and if it is not onto, suppose this is not one onto, then how you will find? Suppose one element y1 you will consider of codomain. Okay, then after then you write f x equals to y1. Then after solving y1 you will get in term of x. Suppose g sorry, here x you will solve. You will solve x, and in term of y1 you will get value of x. If this does not belongs to domain, then you can say that f is not onto. And if a function is bijective, okay, so both functions will be injective also and surjective also. Out of these two, if anyone will not satisfy, then we can say that function is not bijective. Okay, so I hope you understood. Now
Yes, sir.
start question. So question number 1, just exercise 1.2, just see. Now answer 1. Show that the function f, what is it? R star, na? R star to R star, where fx equals to 1 by x is 1 1 and onto. Show that it is 1 1 and onto, where R star is a set of all non-zero real numbers. Okay, so I'm showing how you'll prove. First you will write that function f R star to R star. This is very important. From here you can understand what is the domain and what is the codomain. If it is not given, then it is very difficult to explain it is 1 1 or onto or not. So define as fx equals to 1 by x. Here in questions they are asking to show that. Show that, that means we can consider it is 1 1 and it is onto. So first we have to show it is 1 1 or not. So 1 1 and give heading, we are checking this. So for all x1 x2 belongs to domain. And what is domain here? Prince, what is domain here?
So 1 by x.
R star, and R star is set
0.
of non-zero real numbers.
So non
Okay, so how will prove? We'll consider fx1 equals to fx2. So what is fx1? That is 1 by x1, and fx2 1 by x2. If we'll cross multiply, then x1 equals to x2, right? So if fx1 equals to fx2, then you can show we can show that x1 should be also equals to x2. Its meaning is every distinct element of domain has distinct image in codomain. So f is 1 1. Now prove it is onto or not. So if you want to prove onto, let y be any element of codomain. right? Let y be any element of codomain. That means y equals to fx. So y equals to fx is 1 by x, right? Now solve the value of x. X equals to 1 by y. Since y is a non-zero real numbers, so 1 by y always will be non-zero real numbers. So this is belongs to domain. It means every element, because we have taken arbitrary element of codomain and we have shown here the y has pre-image. Pre-image of y is actually x and its value is 1 by y, and this belongs to domain. That means every element of codomain has pre-image in domain. It means range equals to this line, you will not forget to write range equals to codomain, right? So if range equals to codomain, therefore we can say that f is onto. Okay. Now its second part. Is the result true if the domain R star is replaced by N with codomain being same R star? So answer will be no. Second part, answer will be no. Result will not be same. Result will not be same, because if we'll consider natural number, so here too we are getting pre-image as 1 by y. So if we'll consider 2 belongs to codomain, but its pre-image will come 1 by 2 and 1 by 2 is not belongs to domain. So we can say result will not be same. Only here asking is the result true? That means result will not be same. That means result is not true if the domain R star is replaced by N, okay, with codomain being same as R star. One example if you want, you can give here. So here one example I am giving. 2 belongs to codomain. Now we know that 2 equals to fx. So here 2 equals to, we are getting 1 by x. So x equals to 1 by 2 we are getting, which now it is does not belongs to domain. Okay. Therefore, f will not be onto. If it is not onto, so it is okay. Here we can say that it is not onto. Even 1 1 or not, that if you want to check, is it 1 1? If we
No,
give
sir.
a function, if you replace r star by n, and codomain you will keep R star only. Okay. Is it a 1 1 on? It will not be on 2. But is it a 1 1? Because natural number, if any natural number, distinct element of natural number, if you consider, then distinct image you will get. Here fx equals to 1 by x. So if you consider, if x1 not equals to x2, then always you will get fx1 not equals to fx2. So it is 1 1. You can say 1 1, but it is not onto, not onto. Why? That reason already I have given. Okay. Now question number 2, check the injectivity and surjectivity of the following functions. So today up to question number 2 I'll explain, and then in next video we'll complete remaining question. So answer 2, we have to check it is injective or not. So here function is n to n and fx equals to x squared, right? F n to n, fx equals to x squared, right? Now can you tell it will be a 1 1? First check injectivity. Injectivity. Prince, can you say it is injective?
No, sir.
Why not? Here to natural number. If you consider 1, its image is 1. If 2, then its image is 4. If 3, then its image is if 3, then 9. If 4, then 16. If 5, then 25. That means here for all x1, x2 belongs to domain. If fx1 equals to fx2, fx1 is x1 square and fx2 x2 square, then we'll get x1 equals to x2 plus minus will not put. Why? Since x1 x2 belongs to natural number. It means if fx1 equals to fx2, then x1 equals to f. Here if we'll change this in this n, and in place of n if we'll write integer or real number, then answer will be no, it will not be injective. But if it is natural number, distinct natural number, if you are considering, then distinct images we are getting. So it is injective. It is injective. Now check it is surjective or not. Surjectivity. First think, after that write. Acha, tell me, if you consider value of y is 2, then what will be the image of 2? X will be root 2 plus minus root 2. Neither plus root 2 present in domain or nor minus root 2 present in domain. It means 2 has no pre-image. Here if we consider codomain set, here to all natural numbers like 1, 2, 3, 4, 5. 1 has pre-image, 4 has pre-image, right? Then 9 has pre-image. But what about 2? Here the 2 belongs to codomain. 2 belongs to codomain. And if you write 2 equals to x square, then x will come plus minus root 2. And it does not belongs to domain. Therefore, 2 has no preimage in domain. If any one element has no preimage in domain, then we can say that f is not surjective. Right? That means it is injective, but it is not surjective. If injective, then way of writing already will follow. If it is injective, how to write? If it is not surjective, then taking example will show. But taking example will not show it is injective. It will show taking example, that will not be correct. Right? Understood, Prince?
Yes, sir.
Okay. Now, today, today I'll finish video here, and in next video we'll complete whole exercise.